Alright, so today we're going to look at applications of logarithms, specifically how they're related to the problem-solving process. So we're given this problem. In an experiment, it's found that a culture of bacteria triples in number every 4 hours. So the multiplier there triples. The multiplier there is 3, meaning 300%. So there are 200 bacteria at the start of this experiment, so our initial value that we're dealing with is 200. And the number of bacteria triples every 4 hours. So we'll say n is the number of sets of 4 hours. Okay, so we want to find the value of a here in this chart. So we're given originally after 0 hours the number of bacteria is 200, and look, we can check that with our formula that we've created. So 200 times 3 to the 0, because 0 set of 4 hours is equal to 200 times 1, or just 200. Same with the second one, 600, so 200 times 3 to the, after 4 hours, that's 1 set of 4 hours. So 3 to the 1 gives us 200 times 3, which is 600. Okay, to get the next one, we could simply multiply 600 by 3, because it's going to triple after another 4 hours. So we're going from 4 hours to 8 hours. That's another set of 4 hours. So we know the number of bacteria is going to triple. So we'll have 600 times 3. Which is, of course, 1800. So A is equal to 1800. Or we could calculate that using an exponential equation, this formula that we've created. So 200 times 3 squared, because 8 is 2 sets of 4 hours. We can get that by doing the number of hours divided by 4, and that's going to give us 2 sets. So that is where our n comes from, our power of 2, so we've got 200 times 9, which is 1800. Okay, how many bacteria will there be after 1 day? So, of course, we know there are 24 hours in 1 day. And 24 hours contains 6 sets of 4 hours. If we do 24 hours divided by 4 hours, we get 6 sets of 4 hours. Okay, so n is going to be 6. We can continue to use that same formula. So we still started with 200 bacteria. It's going to triple every set of 4 hours, so 6 sets of 4 hours. So in our calculator, we can do 200 times 3 to the 6, and that gives us 145,800 bacteria after 24 hours or after 1 day. Okay, part C, so we're going to find how long it'll take for there to be 2 million bacteria. So before, when we were answering this question, this kind of question, we would graph it. And we would graph, we'd say, okay, 200 times 3 to the n, where n is sets of 4 hours, is equal to 2 million. So we could graph each of those. We could say y is equal to this, y is equal to this, and look at the intersection of those two functions, or we can use logarithms, which is a much faster approach. But you can definitely still do the graphing if you prefer that. So to use logarithms, we'll want to divide both sides by 200. So we're canceling 2 zeros, and we'll be left with, this is going to turn into 1. So we've got 3 to the n equals, how many zeros? 1, 2, 3, 4. So 10,000. Okay, so let's just check that. We've got 2 million divided by 200. Okay, 10,000. And now we can write this in logarithmic form, or we can take the log of both sides, whichever you prefer. So writing this in logarithmic form, we've got log base 3 of 10,000 is equal to n, okay? Or you could simply take the log of both sides in the previous step, so log whatever, base 10 or natural log, it doesn't matter. Bring down your exponent, so you'll have n log of 3 equals log of 10,000. And then you can divide log of 3 to the other side. And you get n equals okay, so either one. So we can use log base 3 of 10,000, and that's about 8.38. And just to show you, you can also do the same thing and get the same solution if we use log base 10 of 10,000. And then divide that by log base 10 of 3, we're going to get the same solution. Okay, so either way, n is 8.38. So that's n sets of 4 hours, and the question was, how long will it take? So this is n sets of 4 hours. It's nice to give our answer in hours. So 8.38, if we multiply it by 4 hours, we can give our solution in terms of hours. So times 4 is going to give us about 33 and a half hours. And that's the solution to part C. Okay, next question. We've got the value of a car decreasing each year. So this is exponential decay. This value can be calculated using the given function. Okay, so V is the value of the car in US dollars, T is the number of years after it was first bought, and R is a constant. Okay, so we're not given the value of R, but because it's decreasing, we know that it's going to be less than, its value is going to be worth less than 100%. So R has to be somewhere between 0 and 1. Okay. So we want to write down the value of the car when it was first bought. So when it was first bought, then the time that's elapsed is 0, right? So we have 32,000 R to the 0. R to the 0, even though we don't know R, is going to be equal to 1. So 32,000 times 1, or we could see that right away. This is going to be our initial value. So the value when it was first bought is 32,000 US dollars. 1 year later, the value of the car was 27,200 US dollars, and we want to find R. Okay, so this is A1, so A2. So again, that was 1 year later, so time is 1. So we've got 32,000 times r to the 1 is equal to 27,200. Okay, and we want to find r. So we can simply just divide 32,000 to the other side. R to the power of 1, of course, is just r. So we get r equals 27. So it's about, it is 17 over 20. So okay, if we want that as a person, we can say our answer, and we can use the control equals sign, and that'll give us 0.85 as our percent. And what your calculator is really doing is calculating 17 divided by 20. Okay, so 0.85, just a review of decimals. Don't forget, you could also multiply by 5, right? And we could get a denominator of 100, and that would give us 85 over 100, or 0.85. Okay, part B. We're going to find how many years it'll take for the value of the car to be less than $8,000. So let's set it equal to $8,000. We've got our rate now as 0.85. So each year, what that tells us, each year our car is losing 15% of its value. Right. So again, you could graph this. You could graph 8,000, the horizontal line 8,000, and you could see when that's equal to the function on the right side of the equation. Or you could use logarithms. So we can divide both sides by 3,200, or 3,000, no, 32,000. Okay, so we'll have 8 over 32, 8 over 32 thousands, right? But the thousands is going to cancel, so it's 1/4 or 0.25. Let's see, okay, so 8,000 divided by 32,000. I'm going to use the control equals. And we get 0.25. So either way, we've got 1/4. And that's equal to 0.85 to the t. So here we can use logarithms. We can rewrite this in logarithmic form. So we have log base 0.85 of 0.25 equals t. Or we could take the log of both sides and divide them by log of 0.25. Bring down our exponent. Oh, sorry, actually, we want to divide by log of 0.85. Because it's t that we want alone, right? So we'll have t log of 0.85, that's going to cancel. So then we'll get t alone, and that is equal to log of 0.25 over log of 0.85. And that's the same thing that we have right here in this step. So log base 0.825 of 0.25. Remember, with change of base, we can rewrite that in this form as well. So either one. So we have log of log base 0.85 of 0.25, and that's going to be equal to, oh, I did that wrong. Is that a 2? Okay. No, okay. Okay, so we have 8.53 about. Okay, so T, the number of years, is about 8.53. So let's go back to the question. It said, find how many years it will take for the value of the car to be less than 8,000 US dollars. So if you think about it, in the 8th year, it'll still be more than $8,000 because it's depreciating, right? It's getting, the value is getting less. So it's not until the 9th full year that our car is less than $8,000. So in 9 years, 9 full years, the car will be less than $8,000. Okay, and if you weren't sure, if you just had a hard time thinking about that in your head, you can of course just plug it back into the equation. So you can say, okay, so my value, where are we? My value we have 0.85. If I look at after 8 years, so this is 32,000 times 0.85 to the 8. So it's still more than 8,000. We can see that. And then if we plug in, if we simply just change this to 9, so if we go back up and we hit enter, we can change that to 9. And we can see in the 9th year, it's the first full year that our car will be worth less than $8,000. Okay, that's it. Thank you.